Alright guys, in this video here I'm going to be talking about more conversion factors that are of utmost importance for stoichiometry. And one of the first ones is molar mass. Occasionally I might slip up and I might accidentally call it molecular weight. So just in case you hear me say that, or just in case you read that somewhere, and now you know what that is. But I'm going to try to stick to molar mass, because molecules are really just covalent compounds. But this molar mass concept is good for ionic or covalent. So I'm going to try, again, like I said, to stick with molar mass. Now what molar mass is again, it's this way of getting from microscopic to macroscopic, something that we can actually measure out in the lab. It is the formula mass, but for one whole mole of it. Okay, so like let's do an example. Let's do PCl3. We have PCl3, and if I ask you what is the formula weight or the formula mass of PCl3, you would say, okay, I've got one phosphorus. That phosphorus weighs 30.97. And I've got AMU. And I've got 3 chlorines. Each one of those chlorines weighs 35.45 AMU. Atomic mass units, we're on the microscopic level, you can see, because atomic mass units are teeny, teeny, tiny. So the formula mass of that is 137.32 AMU. We're talking about numbers of atoms here. But now let's try to get macroscopic on a bigger scale, something that we can actually do and weigh out in the lab. And all we do is we say, okay, all of the atomic masses on the periodic table, no longer are those just in terms of AMU, but those are actually in terms of grams per mole. And this now becomes a new conversion factor. So if we look at PCl3, if we're just talking about one molecule of PCl3, one molecule of PCl3 weighs 137.32 AMU. But one mole, macroscopic big, of PCl3 weighs 137.32 grams. And now we have a way that we can go to the lab and know exactly how much of each thing we're weighing out. We can even use this to get how many atoms of each thing we're weighing out. I'm not going to go into the background of how this was determined. This was determined, I'm pretty sure, based on carbon and so on and so forth. I'm not going to go into how this was done. But the bottom line is now we can use all of those atomic masses from the periodic table to get information about grams. So let's use this PCl3 in a couple of different ways to show you how powerful this is. So let's say we wanted, I don't know, 7.23 moles of PCl3. How much would we weigh out? Okay, so for some reason you're doing an experiment and you know that you want exactly 7.23 moles of phosphorus trichloride. How much of that phosphorus trichloride would you go to the actual balance and weigh out? You're going to use the molar mass in order to figure that out. The molar mass is gotten from the periodic table. You add up all of the individual atomic masses. So now we're going to say, okay, we have 7.23 moles of PCl3. Every 1 mole of PCl3 weighs 137.32 grams. So we would go to the lab and we would weigh out 993 grams, which is a lot of PCl3. Watch your sig figs, you guys. 1, 2, 3 sig figs, 1, 2, 3 sig figs. Okay? How many atoms is that? All right, and let me insert a new slide so that we can do another little thing here. Let's say, let me ask a whole new question. How many atoms, no, just kidding. How many molecules of, let me make up a new compound, cobalt 2 chloride. Are in 7.27 grams. How many molecules of cobalt 2 chloride are in 7.27 grams? Okay, let's analyze this. We have our starting point. We're going to start with 7.27 grams of the cobalt 2 chloride. We need to know the chemical formula of cobalt 2 chloride. Again, I cannot emphasize enough how important ionic nomenclature is. Cobalt 2 chloride has the chemical formula of COCl2. Really, this isn't a molecule. I went with an ionic compound, so this is how many formula units of cobalt 2 chloride are in 7.27 grams of it. Okay? Now again, let's think about what we're doing here. We're starting with grams. That's a macroscopic quantity, something we can go to the lab and weigh out. And we want to know how many individual formula units are. That's microscopic scale. Somewhere along the lines, we're going to need Avogadro's number. Okay, keep that in mind. You only need Avogadro when you're going from micro to macro or macro to micro. Sometimes people try to jump in and use that all the time. So we know Avogadro is 6.02 times 10 to the 23rd formula units. Let me instead just call that COCl2s in every 1 mole of COCl2. That's the only way that we can use Avogadro. Avogadro is just things to moles. But our starting is in terms of grams. So somewhere along the lines, we're going to convert grams to moles and then moles to units. So we need the molar mass. So what is the molar mass of cobalt 2 chloride? Again, I told you guys, you don't have to do this, like write it out. You can do it in your head. You can do it on your calculator. Cobalt is 58.93 plus 2 times 35.45 gives you a mass, or a molar mass of 129.83. Don't forget your units. That is crucial. The molar mass of cobalt 2 chloride is 129.83 grams per mole. That means that there's 129.83 grams of cobalt 2 chloride in every 1 mole of cobalt 2 chloride. That's what molar mass means. So now we can start our dimensional analysis. 7.27 grams of cobalt 2 chloride. Keep the unit and the label. The molar mass tells us for every 129.83 grams of cobalt 2 chloride, there is 1 mole of it. And then Avogadro tells us that every 1 mole of cobalt 2 chloride contains 6.02 times 10 to the 23rd units of cobalt 2 chloride. So 7.27 times 6.02 times 10 to the 23rd divided by 129.83 gives us a number of formula units of cobalt 2 chloride of 3.37 times 10 to the 22nd units of cobalt 2 chloride. All right, let's do one more conversion factor before I chunk it up. Oh, here's a test or a top hat question. If you were here, I would have done an example just like I did, and then I would have made you do this via top hat. So let's talk about water. What is the molar mass of water? You have 2 hydrogens and 1 oxygen. You guys are going to get this memorized. So that's 2 times 1.01 plus 16. The molar mass of water is 18.02. Again, the units are so important. Grams per mole. Again, just like density, and you guys have been fighting me on density using it as a conversion factor, but here you have to see this as a conversion factor. There's 18.02 grams of water in every 1 mole of water. So I encourage you, if you're really like struggling with this stuff, you can't see that as a conversion factor, start writing it out as a conversion factor until you get used to it. Then, how many grams does 1.45 moles of water weigh? We have 1.45 moles of water. The molar mass tells us that every 1 mole of water weighs 18.02 grams. So that means that we have 1.45 times 18.02, 26.1 grams of water. Last but not least, how many atoms? Let's change this up. Let's change this to how many hydrogen atoms are in 1.45 moles of water. So again, we're going to need Avogadro because we're going from moles, which is macro, to atoms, which is micro. So 1.45 moles of water. Every 1 mole of water contains 2 moles of hydrogen atoms. And every 1 mole of hydrogen is 6.02 times 10 to the 23rd atoms of hydrogen. So what this really gets at is 2 different things. It gets at Avogadro, and it also gets at what a chemical formula means. Every 1 mole of water contains 2 moles of hydrogen atoms. 1.45 times 2 times 6.02 times 10 to the 23rd. 1.75 times 10 to the 24th. H atoms. All right, that's molar mass. Any questions? Let me know.